Well, today we are at the Verla Paper Mill Museum. This paper mill was a working paper mill from the early 1800s to about 1960. This map shows the location of the mill. It was located on a river. The river provided power for the mill and the little village around the mill. This is some of the very interesting buildings, very interesting industrial architecture. This building says 1893. This must have been one of the more modern buildings. This is a part of the guided tour through the museum. You can see the English indications of the various sections of the mill. We'll have a guided tour. I think the guided tour will be in English. This is a part of the small carts or wagons that were pushed. You can see the little turntable. All this was operated by hand to move the logs and the paper from one section of the mill to the other. This is another view of the Verla mill from the outside. We are waiting for the tour to begin. This building that you see is the drying building where the wet paper was placed for individual sheets for drying. The smokestack is a part of the heating system.
With a large manually operated wooden wheel. The logs were wheeled from the timber yard into the mill by the circular saw operators. It was only in the 1920s that a horse was used for this task. In the barking plant, the logs were cut into wooden blocks of half a metre with a hand-operated circular saw. The barking machine was of a simple design, called for skillful handling, unless the operator were to lose his fingers. In the mill there were two grinders with vertical shafts and ratchet feed. Each machine had 8 box-like pockets and a maximum daily grinding capacity of 17 cubic meters of spruce wood. The machines were supplied by the Verla Engineering Works and replaced similar machines with only 5 pockets. Early in the 1920s, a third machine with horizontal shaft and hydraulic feed was supplied by Verla. Following splinter separation and grading, the ground would pulp flowed downstairs to 8 wet lap or sheet machines. Thin layers of ground wood pulp collected on the revolving cylinders of the machines. When the desired substance had been obtained, a bell rang on the machine. Each bell had a distinct note of its own. The operator then split the lap by quickly pushing a juniper stick along grooves in the cylinder. There were 2 grooves and 2 thrusts were required for detaching the sheets measuring 70 by 100 centimeters. The wet sheets were stacked in halves of 5 centimeters, separated by metal sheets, later replaced by plywood. The sheets were loaded onto carts and pushed into the press, where excess water was removed. When this had been done, the pulp was ready for baling and sale as wet pulp with a water content of some 50%. The major portion of the pulp was, however, converted into board. Following compression, the sheet piles were lifted onto carts and pushed into the drying plant along the passageway connecting the groundwood mill with the plant. The heat required for the drying process was generated by burning wood chunks and barking waste in the furnaces. The heating consumed nearly twice as much wood as did the manufacture of groundwood pulp. Combustion gases were let into pipes in the basement and out through the chimney. The pipes heated the air in the plant to 75 degrees Celsius. A firewall divided the drying plant. While sheets were being dried in one section, the other was emptied and refilled with wet sheets. The sheets were fastened individually, in much the same way as when hanging washing out for drying. A cartload of sheets is being pushed into the summer drying loft, where, under favourable weather conditions, the sheets dried in 3 weeks. The sheets were hoisted into the summer drying loft by a hand-operated lift. Vents in the walls of the building made it a pleasant working place, and it was named the Villa. Wooden racks were used for fastening the sheets in the summer drying loft, as well as in the drying plant. During the drying process, the sheets tended to curl, and to counter this, a damp sheet was inserted every few centimetres between the dry sheets in the pile. The sheets could then be flattened for the finishing process. Sheets were fed into steam-heated calendar cylinders. The surface of the sheets was compressed on both sides and slightly glazed. The transformation of groundwood into pulpboard was finished when the sheets passed through the calendars. The quality of the end product is being inspected by the mill manager. Prior to shipping to the customer, the sheets underwent numerous processes in the cell. Since the different qualities had been jumbled together in the course of the manufacturing process, each sheet had to be weighed separately and sorted according to substance range and put in the proper shelf. The work was supervised by the mill foreman. In the corner of his office, he had even something akin to a laboratory. Some of the customers preferred to have their sheets untrimmed, while others wanted sheets with the edges trimmed off. Thin grades were used for making boxes, and the thick substance ranges were bought by binders for making book covers. The major portion of the output was exported, at first to Russia, but in the years preceding World War I, also to Great Britain and Central Europe, and even the United States. When operating at capacity, the mill turned out 10 tons of board and 5 tons of groundwood pulp a day. The board was usually packed in bales of 200 kilograms. Sheet packing, as well as other work in the mill, was traditionally carried out by hand. It was hardly surprising that the end product was called handmade board. When wet, when dry, when glazed, manual labour was used throughout the manufacturing process. Packing and transportation were also carried out manually. Simply because there was no scope for expansion. The time began to run out of small groundwood mills and board mills. The old mill hands were, however, attached to the mill and were allowed to go on working A mill has rarely been closed down in such a considerate way. Finally, is of its own accord, the mill ground to a halt in July 1964. In its heyday, Verla boasted a workforce of well over 100, of which 2/5 were women. The workers served the mill faithfully, sometimes for more than half a century. The mill village was centered on the mill owner's residence, which was surrounded by a well-kept park with imported tree species. The building was erected by Berkeley Private, who managed the mill for over a quarter of a century. Already by the turn of the century, Verla had developed into a close-knit community, governed by the mill owner in a patriarchal way. The same custom prevailed in the working man's family too. The head of the family was very much the master of the house, and the wife had to be obedient. The mill established an elementary school in 1890. Electric light had been introduced in the previous year. A sick benefit and burial relief fund was also set up, and modest pensions were being paid at the same time. The Verla Mill village has gained a new lease of life and serves Kumikummene as a holiday village and training centre. The vintage mill building, complete with machines and equipment, has been transformed into a unique museum, not only in Finland, but throughout the world.
That was the mill bell, and the bell was rung every morning at 6 o'clock when the working day started. Okay, the unbarked logs were floated to the mill and they were hoisted from the river with a hose. This place was about 200 meters that way, and first these logs were stored near the hoist. Here in the mill they used logs that were over 1 year old because they were much more lighter to handle. And the circular saw operators pushed these carts to the mill, and in 1920s they got a horse to help them. So it was a tough job for them. This was spruce wood that was used in the manufacturing process of gravel pulp and cord. Only spruce and water. Those were the raw materials. 3 circular saw operators worked here, and the first one cut the logs into pieces that were half a meter long with this circular saw. The second worker had actually the easiest job here because he just lifted these blocks on the table. This is a debarking machine. So the worker here rotated this block by hand against this revolving blade of the machine. The blade rotated 600 times a minute, and it had 4 these kind of knife blades here. So you had to be really careful and skillful unless you wanted to get rid of your fingers.
Yeah, that looks like the most dangerous
yeah, it is.
job.
But it's amazing, only one accident has actually happened here. One trainee got his fingers here, but he was quite proud of his job, and the story has it that he had said afterwards that the job was actually easier to do here with short fingers. The barking wastes were let outside through this pipe, and they were used as fuel in the heating center of the drying loft.
So these logs are from when the plant was shut down,
Yeah.
1964.
So this one here is a grinding stone. It's from Scotland, weighs about 3 tons, 3,000 kilograms. So this is natural stone, some kind of sandstone quality, Scottish sandstone. And all these stones were brought here from Scotland. And a similar stone is lying inside the grinding machine, grinder, here, inside the machine. These 2 grinders were acquired here in 1903. And these were already made in Finland. There was 1 worker per machine, and he went around this machine all the time, inspected and filled these pockets with these blocks, compressed them against the stone, And there was an egocentric wheel here in the middle, and when it rotated, it made these shafts go like this, to and fro. So this had a ratchet feed, an automatic feed. And when some water came from the pipes, quite soon the groundwood pulp, or some kind of groundwood slurry, began to form. And one machine had a grinding capacity of 17 cubic meters wood a day. The whole process took 43 cubic meters of spruce wood a day. Of that, 5 tons were made into board, 10 tons into, 5 tons made into groundwood pulp and 10 tons into board. Here on the other side you can see the stone in the machine. And there's also a sharpening wheel. And the foreman inspected the freeness of the product, and if he was not satisfied with the quality of the groundwood pulp, then the stone had to be sharpened all over with this sharpening wheel. And of course, when the stones were sharpened from time to time, they got smaller in use, and that's why once a year the stones had to be changed. It was quite a job because all these top parts of the machine had to be removed. All men workers of the factory were needed for the job, and it took 1 weekend to change the stones. So all these machines, there were 3 machines here.
I don't see a lift. How was the stone lifted
they
in?
had some kind of tackles up there.
Oh, I see. In the ceiling.
Yeah, in the ceiling. Of course, it was too heavy just to lift by hand.
And this machine was made in Finland?
Yes, in Finland. And in the very beginning, there were 2 machines from Germany. And they had only 5 pockets, so this was a huge leap forward. Like they had 8 pockets in 1903. But most machines were made in Germany in the beginning. And being the metal part in the stone that was not grinded, and those printers were removed here. But the groundwood slurry flowed down.
So the splinters, meaning the large pieces of wood.
Yeah. Here are the sorters of the slurry. They sorted the slurry according to its freeness again. And in the end, it flowed down to those 8 wet lab machines downstairs, to pipes. 1922, and it used a thermal grinding method, had a hydraulic feed, and the stone is there upright position. So this has a horizontal shaft. And you can see those 3 holes where the wooden blocks were put in.
And this was also electric driven.
No, these were not electric driven, these machines. They used, like there was a water turbine behind the wall. They used to make a shaft go through the wall.
Oh, I see.
So all these grinders were operated by water turbines, water power, till the very end. All other machines used electricity, stone. Well, you can see these long main shafts all over in the mill.
Yes.
And bell-driven machines.
So this was the main drive shaft for this room.
One of them. So you can see
So this was the
all these are wet lab machines.
wet lab machine room.
So the main shaft is made of metal, but you can see there's a big cogwheel down there. All the teeth for that cogwheel are made of wood, white beech. That was quite clever because only the wooden parts got damaged in use. When they used the loose teeth, they were easy to replace by another false teeth. So it would have caused quite a big foundry work if those metal parts would have damaged.
That's right.
So, they only managed with these loose teeth. Factories, one so they could be operated at the same time.
Now this is the wooden gear.
Yes, so this kind of teeth were used in the crocodile. White beech was imported from Central Europe. It was really hard and good wood. It could last like 5 years in use, this kind of tooth. And through this hole, they pushed a metal stick.
Mm-hmm.
And it was locked. Locked in the wheel like this. And the excess water was removed through this sheet and through this cylinder. But these had to be sewn together by, or with a metal string here, by hand. And the worker could sew like 2 or 3 inches a day. It was really tough job. Like here's the result of the other cylinder. It's really mainly work. Like here. Of course, no extra marks were allowed in the sheets, so and the seam of the wire had to be sewn very carefully. Groundwood pulp came from the pipes to this headbox of the machine. And it started to flow down through these pools, and here's the wire that removed the excess water from the groundwood pulp. There was a metal part in the middle, and it divided the groundwood pulp in 2 lines to the spilt. And the sheets began to form on this rotating cylinder of the machine, layer by layer. Now, when the desired thickness was attained, a little wheel came in contact with the sheet, and it, of course, rotated them.
Mm-hmm.
And then a bell chimed, and now these sheets were ready for being removed. All the machines had their distinctive notes, so that the workers knew that, okay, it's my machine that is now ringing. All the workers here were women. They used this kind of stick made of juniper and slid the lap by pushing the stick along this groove in the cylinder. Now this rotated all the time, so you had to be a little skillful. You had to hit the groove at the right time. You could easily go like this, and then the sheets would have been spoiled. And the stick was made of juniper because juniper won't split easily, so it lasted long, sharp in use. And it was also good because the workers had to make these sticks themselves in their spare time. They could use company forest, but they had to take care of their tools themselves. At a time, 4 sheets were formed. They were measured 70 by 100 centimeters. They were stacked here on the table in parts of 5 centimeters, separated by metal sheets or plywood. And there is a press where the excess water was removed from the sheets. And actually at this stage the groundwood pulp earmarked for sale was ready for packing and baling. It was sold as wet groundwood pulp to paper mills, so it was used in paper making. But most sheets were dried and glazed here at Verla, so they were made into board. And next we'll go to the board and drying loft and see how these board sheets were dried there.
It's kind of head box, so it's obviously an open head box, and it flowed through these various pools, as you say, and they kind of overflowed, I guess, from one section to another, and then onto the wire, where a lot of the water went through the wire. And then there was a layer of pulp on the wire, and it was picked up by this felt. And the felt really transported it over to the metal cylinder. Was this type of lap machine common at this era?
Yeah, it was really common. there were about 15 groundwood pulp factories in Finland by the turn of the century, and basically in all these factories they use these kind of wet lab machines. If it was a groundwood pulp and board factory, of course, paper mills had their own machines. They never used these automation here.
So it was still about
So
50%.
wet groundwood pulp.
Yes.
To paper mills. Well, this is a high gravity press.
How long would the board stay in the press?
Well, not for long, just for the pressing stage.
Hmm.
And it's decided that this will be constructing of brick. And this was constructed in quite an interesting way because the new brick walls were constructed around the old mill, so there were no interruptions in production.
Hmm. And the brick building was, you say, 1880?
1893.
93, I see. And it continued to 1964.
Here's installed here high piles. 83 cubic meters of firewood were needed per day for heating the drying loft. That was twice as much as what took the whole manufacturing process itself, so it was quite an amount. The heat firewood himself from the yard inside, and it was quite a job because he had to work 7 days a week. Other workers usually had their Sundays off, but the stoker had to take care that the temperature was high all the time here in the drying loft. So
What was the temperature about in the drying loft?
it was like from 70 to 75 degrees centigrade, so
I
like
see.
sauna.
Oh, yes.
It's generated here in the drying loft by leading the combustion gases through the big pipe system here in the basement. And of course the gases were let outside through pipes, but when the pipes here were glowing red hot, the temperature ended up till 70 to 75 degrees centigrade. Now the sheets can dry here in about 3 or 4 days. Okay, let's go to the first spot. It took a few hours more to get dried. So this drying loft is divided in 2 equal parts by the fireproof wall. While on the other side the drying process was going on, the other side was emptied and refilled with wet sheets. The work was performed by women. They stood on these loose planks here, and there are these metal fasteners in 7 layers without any roofs in between, so it was quite dangerous to go up there just on these loose planks. So the women worked in pairs. The other girl gave the sheets to the lady who stood on the plank, and she hung them up. And these girls were called crows because they worked like birds in a tree. The heating was off for the working hours, but it was really hot anyway, so like 40 degrees centigrade. So the women worked here half naked basically. No men workers were allowed to come here at all to see the ladies work here, except the foreman, of course. He was privileged. And the sheets could dry in 3 to 4 days. In 1910, a summer drying loft was constructed. It was well air conditioned, so it had all kind of vents and holes to allow the air currents to circulate in the building. And if the weather was good, the sheets could dry in about 3 weeks there. And these wooden fasteners, called devil's teeth, were used in the summer drying loft. The village carpenter, Matti Mustonen, had made all these teeth himself by hand, and there were about 40,000 pieces of them there. So it was quite a job for one man.
So this summer drying loft used no heat. It was just a natural heat from the sun and more of a solar drying.
So the summer drying loft used to look like air currents circulated in the building, and that's how the sheets were dried there.
This was probably a nice place to work in the winter, though.
Well, not the summit. Well, this place.
Yes,
Yeah,
this place in the winter.
yeah, but it was really hot to work here anyway. So
So
we
if
had to take some breaks, go to the snow or something, because it was really hot here, and 40 degrees centigrade. It's really hot.
so you say they were making about 10 tons of
Board a day.
board a day, so this building would hold about 30 tons with 3 days worth of drying. Hmm.
There's the calendar room. The two calendars were in the same room where we saw the film. So these sheets were pushed through the steam heated cylinders of the calendars and got slightly glazed and compressed on both sides. But now when the whole manufacturing process was over, all the sheets with different weights had been mixed up. And that's why all sheets had to be sorted separately here with this hand scale. And the numbers here indicated how many sheets there were to 50 kilograms. And the mill preferred numbers from 50 to 120. The thicker or thinner substances could be made. So this is about 60 pieces to 50 kilograms.
So each sheet was weighed.
Yeah, that's true.
So it's 100% sampling.
You can see
All the qualities, their own boxes.
The different weight.
160 sheets to 50 kilograms. But now this place here is really famous. The woman in the middle of the picture, Maria Matson, worked by the scale altogether for 51 and a half years, doing the same job in the same place every day. And actually he is standing on her footprints on the floor. Now, when she stood in the same place, so here's the result. 51 and a half years doing the same job in the same place. So famous footprints on the floor. And actually when Maria got old, her eyesight got weaker, so she couldn't recognize these numbers anymore on the scale. Story has it that by that time she could measure these sheets with her fingertips. And of course the other workers were suspicious, can we trust Maria anymore? Because sometimes she put these sheets in the boxes without using the scale at all. And of course the other workers told the foreman about this, and the foreman checked all these boxes, but surprisingly there were no mistakes. So Maria was allowed to work here for very long, like she was 77 years old when she at last retired. But even then on one condition, if there was an emergency here in the factory, they would have asked her to come back. So it was real dedication to the Verla mill. Sheets were packed into bales of 200 kilograms in this press. So the packers start by putting 200 kilograms sheets under the press with this kind of frame, wooden frame on both sides, and the package was bound with these iron hoops. With necessary markings and stamps, the bales were ready for shipment. And the closest station was the Selänpää station. It was about 7 kilometers away from that one. And
That was a railroad station?
yeah, that was a railway station. So they used horse carts to carry these bales there. And even the sewage water was cycled back to the machines, to the grinders. And the foreman controlled the production in the mill, and he had his own laboratory where he inspected the freeness of the product, and all the lab equipment has been removed here. Okay, there's a date on the wall, 18th of July 1964. That was Saturday, and that was the day the mill was closed down permanently
Oh, I see.
in 1964.
Now you say there was one foreman. Was it Was the mill run in 3 shifts, or was it run 24 hours a day?
In 3 shifts. So people worked 8 hours a day. It was the final stage in the manufacturing process before the sorting. So the sheets were pushed through the steam heated cylinders of the counters, and they were slightly raised and compressed on both sides. So there was no other purpose associated than just making this.
So all boards were calendared then?
Yeah, all board sheets. Here's actually a model of the summer drying loft, which does not exist anymore.
This is that summer drying building.
And all the wooden fasteners were used. There were about 40,000 pieces of them. And a hand-operated lift.
But you say compared to the 3 days with heated, this took 3 weeks.
3 weeks, that's true. These fasteners.
So this was not quite so hot to work in.
No, it's quite pleasant to work in. Summertime, of course, it was not in use at the winter time.
And this was created for extra capacity, additional drying capacity?
Yeah, or in order to cut heating expenses at the summertime.
This is the dates of the Verla mill, 1872 to 1964. From the view of the Verla mill, to the left was the finishing room with the steam heated calendars, and in the center was where the wood came in and was debarked, and to the right on the top floor was the weighing and packing room, and on the ground floor were the refiners. And as we learned, across this wooden walkway to the drying house, modern drying house built in 1893, a brick construction to eliminate fire. This is a small stream that supplies water and was turned into power for the mill. This is looking upstream. So the water came under this bridge and followed along the right bank, and as you can see, the mill buildings. There was power generation. They are doing construction, but that water came through the this area, and then the dry shafts went into the building. The waterfall is still remaining, of course. That's Mother Nature. And now there's a modern electric power generator at that small red building on the left. And there recent construction of a dam to divert the water to that building. So these are the mill buildings. The logs were brought in just behind that tree into the building. Water flowed next to the building for power. And this home was the owner's home. Obviously, he had the nicer home in the village.